Hello, everyone. From this class, we will learn the 4-axis machining of embossing machine convex roller. In this class, we first learn about the process preparation of manufacturing convex roller. We know that the principle of the aluminum strip embossing machine is to roll aluminum strip with a thickness of 0.2 millimeters by using convex and concave rollers. Therefore, the quality of the manufacturing roller affects the embossing quality of the aluminum strip. We first analyze the drawing. 1. The main body of the piece part is a cylinder, and the pattern is distributed around the entire circumference. 2. The middle dimension of the convex roller is marked with no toll, that is, free toll, which is plus or minus 0.2. 3. The minimum concave arc radius of the pattern is 1.5, which is important to select tools. Next, analyze processing, machine tools and tooling. 1. Adopt CNC 4-axis milling machine, that is, XYZ plus a 4-axis. 2. Adopt 1 clip and 1 top clamping, 3 jaw check and top. 3. Adjust the parallelism and ensure that rotary center is not eccentric by hitting the table for correction. Materials and tools. 1. The workpiece material is number 45 steel. It is a high-quality carbon structure steel, not too hard and easy to cut. The lathe is used to process the blank first. 2. Tool selection. It must be based on dimension measure, manufacturing efficiency, reliability, and other factors. Through process analysis, we adopt the principle of process planning. First roughing and then finishing, first bottom and then wall. Primary manufacturing processes include 1. Base manufacturing, 2. Waveline manufacturing on both sides, 3. Pattern face manufacturing, 4. Fillet face manufacturing. Let's open UG software and first complete manufacturing preparation before the convex roll processing works. Firstly, measure the related dimensions to obtain the basis for selecting tool. Click Analysis, Measure Distance. Choose the distance and type, and activate Point on Curve Snapper. We first select large region on cylinder, find the relatively narrow place, grab the point on the curve, about 11.6, and then select circumferential contours at both ends, about 8.9. Therefore, we know that on the cylinder surface, the roughing tool we can use is D10. And then continue to measure radius of the bottom concave fillet in this region. Click on Partially Radius and select the fillet face. And the minimum radius is 1.5 millimeters. 1.5 millimeters. Based on such measurements, we first create the roughing tools on large surface. Click on Home, Create Tool, Flat Bottom Tool. Name D10. The circumferential contour on both sides is 1.5. So the tool we create can have two plans. In the first plan, select the toroidal cutter, D6 or 1.5. Set the diameter to 6 and lower radius to 1.5. Knowing the radius of the toroidal cutter, we can rough the fillet. In the second plan, we can use the ball cutter or 1.5 directly. But the ball cutter or 1.5 has small strength and poor rigidity. So in use, we must pay attention to the cutting parameters. For the finishing large surface, we can still use D6 or 1.5. Let's continue to measure related dimensions inside the pattern. Click on Analysis. Partially radius is 1 mm. 1 mm. The radius of the bottom fillet is 1 mm. Click on OK. Click Measure Distance. Select relatively narrow region and grab the point on the curve. 2.1. Therefore, for the roughing tools of pattern, we can create toroidal cutter, D4 or 1. OK. Diameter, 4. Lower radius, 1. By using the toroidal cutter, the bottom part and the connected bottom fillet are roughed at once. Then the finishing of pattern can also be done with D4 or 1. The fillet of the top surface, which is convex fillet, does not limit the radius of the tool. We can use the ball cutter or toroidal cutter as long as the tool has fillet. We then create blank and switch to the modeling module. Click Extrude and select Cylinder Edge. The length of it is consistent with the length of the workpiece. Click on Offset, one side, end with 2 mm, and wrap the workpiece. We need to note that the Boolean is none. Preview. You can offset slightly larger, 2.5, and OK. Blank the blank and switch back to Manufacturing module. Click on Geometric View, double-click Workpiece, specify the blank, display the blank. Select the stretched cylinder as the blank part and blank the blank. Click Display to see if the part is appropriate. No problem, OK. Click Operation Navigator and then set Manufacturing CSYS. If the chuck is blessed at the right end, then our CSYS should be set at the left end. Double-click the MCS, CSYS dialog and refer WCS, which is the work CSYS. Fine, at the beginning, our work CSYS is set on the left end face. At the same time, we must note that the 3-axis direction of CSYS should be consistent with the machine tool CSYS. That is, the up-down direction is the Z-axis, the left-right direction is the X-axis, and the front-back direction is the Y-axis. Security setting. Select cylinder. Click on Specify Point, CSYS Origin, and OK. Radius. Click on Analysis, and after measuring, the diameter of the workpiece is 80. It means that our radius can be set to 50. Alarm, no security setting axis is specified. Specify vector, select X-axis, and click on Display. Fine, look at the dash. This is the position of the tool in the transfer process, which must be greater than the blank, and OK. We have already set the 3 process preparations of tool, workpiece, and CSYS. Have you learned the preparation of manufacturing convex roller? Please answer the following questions.